she can say in her voice.
Hello. Well, today you've come to watch me explain the rates of change in the natural and social sciences. So that's what I plan on teaching. All a rate of change is when you have a change in anything and you calculate the rate, or how fast, how slow, how constant it's going. So for the natural and social sciences, we're going to do velocity and acceleration. And for the social sciences, marginal costs. So first we're going to look at the natural sciences. We're using velocity and acceleration. What is a rate of change in this sense? What is the difference between velocity and acceleration? How to find when a particle is speeding up or slowing down? The distance traveled? And things of this nature, but what's really important is that these are all rates of change and they all have to deal with rates of change. So what is a rate of change when you're talking about a moving particle? Say you have a fancy sports car. Oh my gosh, so fancy. And you have it moving along some sort of measurement, and its position on Earth is moving. Now this sports car has a position, and therefore it has a position function. Since it just travels at a constant rate throughout the whole process. Just be like that one. Constant rate. But say it has some sort of, sometimes it's speeding up, sometimes it's slowing down. And all of a sudden, you have variety in your y-axis. Okay? Its position is still moving along this axis, but its velocity may be changing. And that's what this is. Okay? So like I said, anything can be a rate of change. You don't necessarily have to have acceleration, position, velocity to have it be a rate of change, especially in the natural world. For example, my grade can be a rate of change, but I wasn't assigned exponential decay. So here you have our Bugatti, and I know what you're thinking, David, that's not a Bugatti, that's like a Honda at best. Stop. But the point is, it's moving, and that's its position. Just, it's moving. Its velocity is if it's speeding up or slowing down. An important concept to remember, velocity can be negative and it can be positive. But all a negative velocity means is that it's moving in the opposite direction. It doesn't mean necessarily that it's slowing down. Very important. Acceleration, on the other hand, is if the speed is going faster or it's going slower, okay? So like 40 miles per hour to 60 miles per hour, acceleration is going up. And so that's pretty much all you have to remember in terms of context for doing these problems, and we'll do some practice problems shortly after I explain marginal costs, which you're all very excited for. And what's important about marginal costs is you have a cost function. Something costs this much to make. You have a revenue function, which is how much somebody makes in total. And then you have your profit. Oh, that's not that kind of profit. Like if I say I'm going to get an A in this class and I'm right, I'm not a profit. I'm not a profit. So it's how much you really make, and then minus the cost is the profit. Okay. And I know what you're thinking, but David, where's the rate of change? Your project is on the rate of change in social sciences, not just the social sciences. I know. Marginal costs, on the other hand, this is just the cost and revenue and profit and things like that, which is all great, but the rate of change, the reason why you're here, is the marginal cost. And that is a rate of change. Because the marginal cost of something, of producing a number of products, is the same as calculating the actual cost, or it's approximating the actual cost of that number plus one product. So the cost approximately of the next product that you're going to make. And that itself is a rate of change. So we'll do some practice problems so that we can understand this. So the velocity function is just the slope of this, right? Because you want to see how it's changing. And you would get your function to be the derivative of this if you're trying to find the slope. That's fine. At time equals 2 seconds, well, you just plug in 2 into your function over there. 3 meters per second, remember your units. Okay, so you just plug 2 in. That's all great. To find out when the particle is moving forward, all you have to know is that velocity is positive when the particle is moving forward. So it would be positive if t is less than 1 and greater than 3, and negative when t is in between 1 and 3. Okay. What about at rest? Easy. It's at rest when this velocity is at 0. So at t equals 1 and t equals 3. It's very basic. Acceleration is the derivative of this. So remember, velocity sign is positive only when the particle is moving in a positive direction, okay? It doesn't mean that it's slowing up or speeding down when the velocity is positive. Likewise, when acceleration is positive, it just means the rate of speed is increasing. None of this means that it's speeding up or slowing down. What does mean it's speeding up or slowing down is when velocity and acceleration agree. So one particle is going in one direction and the acceleration is following it. If they clash, then velocity goes in one direction and acceleration pushes against it, so it's really slowing down. And that's conceptually how it works. So this is your cost function. All it's saying is that at x units, that's how much it costs. Okay. The marginal cost function is just the derivative of this. So marginal cost, effectively, is going to mean the slope. Say this is your cost at x. The slope at x plus 1. And that is going to calculate for you the cost of this next function, x plus 1, because that's the slope. You're calculating the slope. Okay, do that. The marginal cost function is going to be, how much does it cost to make 501? Well, you plug 500 into this, which is just, and that's your marginal cost. Well, I hope you've enjoyed this. I certainly enjoyed it.